and welcome back to Calero Academy. Today we are going to derive a basic trig identity. The trig identity we're going to derive today is a very basic one. It is that sine squared theta plus cos squared theta is equal to 1. We're going to prove this today. Now there are two ways to proving this identity, which means that it is always true no matter what situation we have with the right triangle. There are two ways. The first one is a little bit harder than the second one, so I'll show you the first way too. Let's put plan A, proof A, and so the way we're going to derive this identity is that first we're going to draw a right triangle. And this angle is going to be theta, and the hypotenuse here is 1. Now we don't need to know this one because we already know it's 90 minus theta and it's not important, so we won't write it. So this side, let's name this A, and this side B. So A is equal to cos theta because cos theta is equal to adjacent on hypotenuse, and this is sine theta because the B is equal to B, which is opposite on hypotenuse. Thankfully, this is 1, so it cancels. And so now we're going to do a little list of some sine cos, and so we're going to do sine theta is equal to sine theta is equal to B on C, opposite hypotenuse, and so sine squared theta is equal to B squared on C squared. Cos of theta, however, is equal to A on C, and therefore cos squared theta is equal to A squared on C squared. Now it's important to remember the fact of the Pythagorean theorem, which is A squared plus B squared is equal to C squared, because since we can get from this C over here, taking from all of these things we wrote down, we can turn it into since sine squared theta plus cos squared, so sine squared theta plus cos squared theta is equal to sine squared here, theta is equal to B squared and C squared, and cos squared theta here is equal to A squared on C squared. So when you add these up on the shared denominator, you get A squared plus B squared on C squared. Now this is really important because look, we can take this here, and look, we can substitute here the left hand here for the denominator in this fraction, and it cancels out, and we get A squared plus B squared on A squared plus B squared. So this is equal to 1, so we've just proven doing the hard way that it's not really hard, it's just a bit more harder than the other one. So here so we've proven that sine squared theta plus cos squared theta is equal to 1. So now we're going to go up here, back to our main page, up here, see if you can see that. Okay, here, and that was proof A. Now we're going to do proof B. It's very easy. Look here. We have our triangle again. And this is theta, this is 1, this is cos theta, this is sine theta. Now, using the Pythagorean theorem, we just get that cos squared theta plus sine squared theta is equal to 1. Now that is so much easier than having to do this. But remember, you shouldn't memorize this. Although you should kind of memorize this, but you should always be able to always derive this, which is really easy if you've seen here, and I would recommend using proof B because it's much more easier to derive and also if you want to memorize. So that's proof B. Now I want to show you in the next video we'll be doing something a lot harder, and we're gonna prove that what is sine of theta plus phi. This is our other angle in a triangle. If I only know what sine theta, cos theta, sine phi, that's how you say it in Greek, and cos phi is, how do I figure out sine theta plus phi if I only know sine theta, cos theta, and sine phi, and cos phi? We'll be doing this in the next video. It's called the double angle formula, and we can derive this. And it's called the double angle. Actually, sorry, it's called the angle sum formula. So the angle sum formula tomorrow we'll be proving in our next video that sine here of theta plus phi is equal to sine theta cos phi plus sine phi, sine phi times cos theta. So let me address a little question here. Some of you watching this might be thinking, well, this is very easy because we can just say sine theta plus sine phi. But that's not the real answer. You know, it doesn't work this way. It only works in multiplication, because when you're dealing with this, it's not linear. If you plotted this thing as what we have done before, if you plot this thing, it comes out it's not linear, because we can do a table chart. I'll just show you this quickly why you can't use that sine theta plus sine phi, because look, we can make a little table here. And this is our thetas, and this is our sine thetas. This is our x we can call this, and this goes out f of x. And so here we can use 0, sine theta 0, sine 0. 30, however, this becomes a half. This is 45. This becomes root 3 on 2, which is root 2 on 2, which is equal to 0.7 about. And this, you put 60 here. This is root 3 on 2, which is 0.85. And sine, you put theta is equal to 90, and sine theta is equal to sine of 90 is equal to 1. Now you see here there is something wrong with this chart. It's not linear. Look, as the difference here goes by 30 to 60, and then 60 to 90. And look, this is not linear. Look, every 30, look, this changes this changes 0.5. This thing changes 0.5. And look, and then the second 30 block from 0.7 to from 0.5 to 0.85, it changes to 0.35, and then from 0.85 to 1, it changes to 0.15. This is not linear, because look, for every 30, this jumps 0.5. The next 30, it jumps 0.35, and the next 30, it jumps 0.15. If this was truly linear, it would go in blocks, like 30 rises 0.5, another 30. But when we're dealing with trigonometry, you can't use the same distribution form of commutative stuff with this as we've shown before, because it doesn't come out linear, because they're not the same. They're not the same. What do you call it? You jump 30 degrees here, it doesn't jump the same number. So, as we said before, tomorrow in the next video we'll be showing you how to prove the angle sum formula, which is sine theta cos phi plus sine phi cos theta is equal to sorry, I forgot to say, is equal to sine theta plus phi. Thank you for watching this Calero Academy video, and we hope this helps you look, because this identity, including the angle sum we'll be doing tomorrow, is very useful when you're solving a trigonometry question. Thank you for watching, and stay tuned for tomorrow's video of angle sum derivation.